All right, guys, here comes page 2. All right, so we want to try and identify some relationships. In this situation over here, angle 1 must be congruent. Now, the only angle that it really has to be congruent would be the angle across from it. Those are called vertical angles. So angle 1 must be congruent to angle 5. Angle 6, if we look at its vertical angle, the vertical angle to angle 6 is actually a composition of a bunch of angles. It's whatever this angle is that if we combine angles 2, 3, and 4. Next idea, what angles up there would have to equal 90 degrees? Well, this box right here means 90 degrees. So this angle is a right angle, and it's composed of angles 2 and 3. Which angles would have to add up to 180 degrees? Here, we're looking for linear pairs. I'm looking for angles that if you put two angles together, then they form 180 degrees. You got a couple options. Angles 1 and 6 would make a half circle worth of degrees. 6 and 5 would be a correct answer. You just got to choose one of those. So I'll just go with angle 1 and 6. Angles 2 and 3, we already know they add up to 90 degrees. That's called complementary. And angles 1 and 6, we said are a linear pair, and we know that those add up to 180 degrees. So supplementary means add up to 180 degrees, and they would also be a linear pair. Okay, now, same situation. If angle 2 happened to be 60 degrees, and angle 5 was 50 degrees, it's a really good idea to put them physically on that diagram. Now, let's see if we know the measures of any other angles. Well, we know if this is 50 degrees, angle 1, which is vertical to it, they have to be the same measure. Angle 3, well, we know 2 and 3 add up to 90 degrees. If 2 is 60, then 3, it's got to be the rest of that 90 degrees. Angle 4 here, I do know that this straight line means that all of these angles, 2, 3, 4, 5, all have to add up to 180 degrees. So far, I got 90. 4 and 5 would have to be the rest of that 90, which means 4 has got to be 40 degrees. Angle 6, I know 1 and 6 add up to 180 degrees. If 1 is 50, the rest of that 180 degrees would have to be 130. We got them all. Next, here's probably the most important part of the test. Trying to understand certain situations and take some expressions and write a good equation. Well, they said that these two, wxy and yxz, are complementary. I know that means that they have to add up to 90 degrees. That means I can take those expressions and add them up to equal 90 degrees, because they told me the relationship. So I needed to write an equation. I wrote the equation. Now we got to find the measures of both angles. The only way to do that is solve for x. First thing to do is combine like terms. We have a total of 7 x's over here. A negative 18 and a positive 3 is going to be a minus 15. Going to want to use an opposite operation. Do it to both sides. Add 15 to both sides. So get rid of that 15. I'm down to 7x equals 105. And divide both sides by 7 gets me an answer of 15. Now, make sure you understand, none of the angles actually measure 15. That's what x is. I need to actually take 15 and plug it in if I want to find that angle measure. 5 times 15 is 75. If I take 18 from 75. I think I get 57. Okay, my other angle, again, plug in 15. 2 times 15 is 30, plus 3 gives me 33 degrees. And the good news is these two do add up to 90 degrees, so everything's looking pretty good. All right. Doesn't look like this one is too readable. They're trying to say AT bisects. Now we studied on the last page. That means we're going to be cutting something in half. So I need to draw this. I want to get a good visual of what's happening. M, A, H, and I've got A, T, cutting it in half. If I cut something in half, that means this angle's got to be the exact same as this angle, whether I did a good job drawing that or not. Well, they said that MAH, the entire angle, is going to be 3x minus 31. Angle TAH is 2x minus 5. And since these are equal, I can call the other one the same thing. I need to write an equation that 2x minus 5 would equal 2x minus 5, but making that equation is not going to help because everything would cancel out. But I do know from the angle addition postulate that if I take the two small angles and add them up, that they have to equal the large angle. And now I can go through my solution process again, combining my terms. I've got 4x's minus 10, and I can't do anything to the right yet. I always believe in handling the x's first. There's more x's on the left side, so let's get rid of the ones on the right side. I'm down to x minus 10 equals a negative 31, and if I add 10 to both sides, I find out x is negative 21. I'm not going to freak out about that because I'm pretty solid on my math. I think I did a pretty good job. Now, the problem is I kind of stole this problem off of the test and changed the numbers and didn't check. This is going to get us kind of a messed up situation, but we'll have to just flow with it for now, because if I want to find the measures of all these angles, I got to plug in this. 2 times negative 21 is a negative 42. I'm getting some negative answers, so Coach Foss did not do a good job of checking this review. So my two angles that are equal would be here, and then I have a negative 94 if I put them together. Sorry about that. The setup was important, though. And the last problem on this page, what is the midpoint of AB if I give you the coordinates? Well, there is a midpoint formula. If you're writing down your formulas, you can grab them whenever you want. So I need to add the x's. If I want to do negative 5 plus 7 and divide by 2, I'm just averaging the x's, and then I got to average the y's. So negative 5 plus 7 is actually 2. Divided by 2 leaves me with 1. 8 plus 10 is 18. Divided by 2, 9. There is my midpoint. And that is page 2 of the review.